Hi, good morning my dear students. Yes, yesterday our previous class we have discussed a lot of things on the inverse trigonometric function. In the inverse trigonometric function we are going to consider 1, 1 and 2 bisective inverse. Especially basic concept we have studied in the last class. Now most important concept of the inverse trigonometric function. So in that part, we are going to express for the R6 trigonometric functions how to work on the some conditions. Several functions are there. Some functions only which is having for the 1, 1 and R2. Some function does not. So that we can talk here about the inverse and 1, 1 and 2 bisective. Let us discuss first sine function, right? So I hope you know that sine function. In the basic concept, you know that we are going to express for the value sine such that, right? So R implies minus 1 to 1, right? The setup here, the domain of the sine function is the set of all real numbers, right? Numbers and range is most important. Minus 1 to 1. Range minus 1 to 1. This is the clear picture about this value. In this case, when you are going to take some restriction, some conditions, some factors, now we are going to deal with it. So restriction of the sine function, sine, right? Such that, shall I take minus pi by 2 implies minus 1 to 1. How am I going to take? By the restriction, by the condition that value or real number will be changes. I am going to define minus pi by 2, then only minus 1 is the 1 and 2, right? And 2. This function will be, say that by the way of the expression we are going to take inverse, sine inverse such that changes this one minus 1 to 1, right? Implies, so minus pi by 2, right? Is 1 and 2 bijection. Hence it is called the inverse function. Clearly I can say that. So by the way of the past interval, we are going to define for the sum theoretically by the graphical way. So here sine function, I am going to take values, the expressions of the all the things, theta. So here shall I take sine theta? Here 0, pi by 2. Here shall I take pi, right? 3 pi by 2. Here 2 pi, right? So only for the sine theta, I'm going to deal with. So here pi by 2, right? You are going to take unit circle also. This is a simple one to express for the 3 pi, right? So by the way, you are going to express on the wave 0, 0. So here pi by 2, here pi, here 3 pi by 2, here 2 pi, here x, it means A, B, C, D. The first quadrant, second quadrant, third quadrant, right? Here fourth quadrant. All these things are helpful for what? A sine inverse trigonometric function. Sine 0, 0. Sine pi by 2. Sine pi by 2 is 1. sin pi 0, 3 pi by 2 minus 1, right? Here 0, here you can express pi by 2, 1, 2, 3, 4, pi, here positive, right? So pi by 2 is there, you can express for the value. So how you are going to take? Here 1 minus 1, here plus 1, right? The value, it exists, sign positive, here 0. So on the value, plus 1, minus 1. By the way, you are going to express for the values. So pi by 2, 3 pi by 2, right? This is the close interval, comma. So next, 3 pi by 2, 3 pi by 2, and pi by 2, right? So one factor and another one, pi by 2 minus pi by 2, right? This is the value that factors, and here the graph will be going to only for the in the form of y-axis or x-axis. Both you are going to take. In this factor, first I am going to take x-axis. So here I am going to range here minus 1, here plus 1, pi by 2, pi, here 3 pi by 2, here 2 pi, here pi by 2, right? So this one minus pi by 2, right? So this means minus 3 minus pi. So here minus 3 pi by 2, x dash, here x, here y dash. So the point sin theta is 0, 0, no problem. So sin pi by 2, the range will be up value. So sin pi 0, right? So 3 pi by 2 minus 1, that range is there. 2 pi goes on 0, right? So this function y is equal to f of x is equal to sin x. The class intervals goes on up, down and up and down. Here that, here and here. So this means, shall I go to here, minus 3 pi by 2, minus pi by 2, right? The class interval restriction condition are applied. So minus pi by 2, pi by 2, this is the factor. So here pi by 2, in the positive side 3 pi by 2, right? So the principal branches of sine interval minus pi by 2, pi by 2, the same manner you are going to express for the in the factors of y dash, the range here plus 1, here minus 1, x dash, x, right? The factor y, x is equal to f of y, it means sine inverse function, right? Sine inverse y, otherwise you can take inverse. So here pi by 2, here pi, here 3 pi by 2, here 2 pi, right? So here minus pi by 2, minus pi, minus 3 pi by 2, right? You can take a graph 0, sine exists 0, here 0, right? Sine goes on positive, the big value, minus, right? You check it, and goes on negative and down, like that. So here also graph up, here down, and goes on value by the graph of representation. So these are we are going to deal with the sine function and sine inverse function. Maximum they are asking university, and the fixed question, the principal branches of the sine inverse function is minus pi by 2, pi by 2. So range and domain is minus 1 to 1, and the range is minus pi by 2, pi by 2. So this is the required and most valuable answer, and this one we have discussed in front of you. In the next class, I am going to discuss another most important things, cos value. Thank you so much. I will continue the next video. Bye.